So you can use this if you like, or you can use just the keys like normal.
Okay.
Just letting you know, and I think this also has a pointer.
Okay.
That works. Okay. We are live, so it'll still be recorded.
Okay.
And you still live. All right, good morning. So thank you for being here. It's my pleasure to introduce you to today's seminar speaker. This is Dr. Geoffroy Lesage, a friend and colleague of mine coming from Montpellier, France. I met him in 2016 while I was a postdoc. And at that time, I knew I was going to be starting at LSU, and so it's been my pleasure to collaborate with him on combining membrane technologies with wastewater treatment, water reuse efforts. So he's a membrane expert, teaches many courses from kind of environmental engineering to chemical engineering type of material. And I know a lot of you are civil engineers here, so I've asked him to give a bit of a bigger picture for the wider audience. So I think you'll enjoy hearing this, no matter what you study. So please welcome Geoffroy.
Thank you. Thank you very much, Sam, for the really nice introduction. I'm really pleased to be here again in Baton Rouge, my second time. And I would like to thank you to be there this morning, Friday morning, to follow my speech. And I just realized that I forgot to put a map of France to show you where is Montpellier, because it's my second time. So I wanted just to start with the topic of my talk related to water resource recovery factory. But yeah, so Montpellier, just a short introduction, it's south of France, near to the Mediterranean Sea, not far from Spain, not far from Marseille, maybe a bigger city in France, some could know. So we got a nice university, nice weather, and we are really pleased also to have close collaboration with LSU and Sam, and we are really pleased also to welcome some students from LSU in end of May. And so that's a nice place. I'm really glad to live there, but I'm also really glad to be here in Baton Rouge, Louisiana, and enjoying your nice place. So, related to what I wanted to talk with you. I put the name of my colleagues Marc Héran and François Zawiska, who are professor and associate professor at University of Montpellier, because we are working together on those topics, and so they participate to those kind of slides that I prepared for the show. So my lab, his name is Institut Européen des Membranes, which is for Membrane European Institute. So mainly you understand that it's dedicated to membranes for separation, and related to our lab, around 2/3 of the people over there are chemists and are working on elaborating new membrane materials, organic or inorganic materials for membrane separation, which could be for different applications. Could be for air, for water, for energy, for food processing, and many things. And 1/3 are chemical engineering, environmental engineering, and we are trying to use those membranes for different applications. But in my case, I'm working mainly on wastewater treatment, a little bit on water treatment too. And I wanted to give you today some interesting figures, really, or something related to the new trends of water treatment. So the goal to change from waste to resource and recovery of resource, recycling, circular economy, and everything. So please don't hesitate to interrupt if you have any questions or if something that I say is not clear. I would be really pleased to answer you. So yeah, I will start with these slides that I take from UN, United Nations. And it was just to remember everyone about what they say, the human right to water, which are some minimum requirements for every people all around the world related to water. So they say that, for example, we have to get, sorry, because the data are in liters, and I know or it's gallons or something, but I'm not really clear with the conversion. But yeah, they say that, I'm not sure if everyone knows how much water you consume every day, but the minimum needs are between 50 and 100 liters. When we say that, we are not talking only on water that we are drinking or we are using for the showers or for the kitchens, but we are talking about the water that we consume by everyday way of life. So it means when we eat, when we go to car wash, when we are using a swimming pool or something, we use water. So, but here we are not talking about using swimming pool, we are talking about the minimum requirements of water. So it's between 50 and 100 liters. And if we are looking at all around the world, this consumption of water, everyday water, are really different from the place you are in the world. You know, in Africa, in some place where there is really not too much water, the water consumption per person is around 20, 30 liters per person and per day. And in some place where the habits are really different and more advanced maybe, like for example Canada or Australia, or maybe here, we can go up to 1,000 liters per day and per person. So there is a huge range of water consumption. Also, when they are talking about human right to water, they talk about the distance you have to get to find a water source. So for us in France or here in Louisiana, you have just to take tap water. You know that it's drinking water. You can use it, no problem. They are everywhere. But and some other place in the world, they say that the water source has to be within the 1 kilometer from your home. So 1 kilometer, you imagine when you want to brush your teeth, you have to do 1 kilometer, or if you want to do the kitchen. So it's not the same case. And then there are also some data related to the cost needed to buy some water and to the collection time, because for us it's the same. Tap water, direct water. No, we don't have to wait. But in some place you have to take the time to pump the water from the soil. Okay, so 30 minutes could be really long too. Okay, so that was just the introduction. And another introduction, I'm sorry if my talk at the beginning is not so happy about what's going on in the world with water. And but yeah, the population is increasing. So we reached 8 billion last year. And if we see the data from 2000 and 1900, you see that it's growing really quickly. And there are still some people all over the world who are suffering from no access to drinking water, no sanitation, and no electricity. Everything is linked also. And on this map, you see that there are some places right not far from the equator, where mainly in Africa and India, where there is a lot of trouble related to sanitation access. And the goal is that those population without sanitation decrease, the number of those people decrease, and so what is the consequence is that we will need more water, and water in some place where there is not too much water. So yeah, global population of the world is growing. Okay, we are talking about 10 billions in 2055, and in the same time, we increase the needs of water. And I found those interesting data relating to the worldwide water consumption every day. So if we see in cubic meter per day, nobody could imagine what it is, but it represents around 50 Olympic swimming pools per second of consumption all over the world. And this consumption is growing. So they say that UN says that by 2050, the worldwide water consumption will grow up to 20-30%. And what is the main consequence is that more and more people will suffer from water shortage or no access to water. So that's the trouble, and we have to find some solution for that. But the trouble is that it's not only linked to water population, to worldwide population. It's not only linked to the fact that we need more water and water to feed all those population, and it's also linked to the climate change. And I found those data also, which are interesting. One on the bottom is from Australia. It's a stream flow of the Western Australia rivers, and even if we are not convinced about climate change, those figures, those data shows clearly. So the time can start from the early 90s, and right now we are around there, and you see that quite clear that there are less and less stream flow in those part of the world, and there is not only less water from the sky, but there is also some other phenomenon like drought, like flood related to water, and it compare the 20 years before 2000 and the 20 years after, and you see that there is an increase. So all those kind of increase of droughts and flood and storm could also affect the access to water. And just a little focus on what's going on in France, because in France, everybody are quite shocked about what happens last year and what is now happening in 2023. Because last year the drought was really, really severe during the summer, and we got some plan of, alert or crisis when there is some water shortage in some place of France. This is France. This is the time to show you Montpellier over there. Paris is over there, and the color are linked to the level of the water crisis. And last summer, and it was in 26th of August, almost all France was in water crisis. So except a little bit of Britain, without no problems for water, all the French department or French counties were under water restrictions, and so it was around 97% of the French territory that was affected by this crisis. And as a consequence, what also shocked the people is that there were more than 100 municipalities where there were no more tap water during the summer. So they are obliged to distribute, to give some water in bottle. And that was something really shocking for the people, because I remember 10 years ago when I was teaching about wastewater treatment to my students, I was saying, okay, maybe in one later there will be some water trouble in France, but right now it's not the case because we have a lot of mountains, river, and surface water, so no worry. But right now it's the situation of 2022. And 2023, what's going on is that we got a drought during the winter. So we got the first the first counties in crisis in Pyrenees, close to the border of Spain, and it has started in March. So it's beginning crazy, because a drought in March normally in France it's like really cold, a lot of rain, but no rain from Christmas to this time. So we are experiencing this, and so this is the case. So in France, this is a hot topic, water. So everybody told me, you are working in water. Oh yeah, this is the time for you for your job. Yeah, it's a long time we are working on it, and right now maybe we hope it's not too late. But so this was just the situation, and now I will try to be more optimistic or more positive by showing you some possible solution for those problems. Okay, so well, I'm sure that everybody heard about the Sustainable Development Goals from the UN, and those goals are, really good hope for the future. And what is quite new is that we have got an integrative way of solving the problem by trying to solve different issues or to get some different goals, but in a circular way or in an integrative way, between food, okay, energy, and water, because everything is linked, and you cannot try to solve a problem one by one. You have to think about a global image. Yes, so yeah, I just show some SDG related to water, energy, and food topics, but there are another SDG. Mainly the main SDG is clean water and sanitation access for everybody. But as you see in those pictures, there are some links between water and food. Links for example, water is used for irrigation mainly, and the energy is the same with food, energy with water, and yeah. So this is the way we try to solve the problem, or to find some research topics by integrating everything. And what is also a part of a start for our research project was also this report from UN in 2017, so it's like 5 years ago. But it was quite interesting information related to the wastewater, and wastewater as a resource, because in wastewater we hear waste, so waste we have to discharge it somewhere. But in this report, what is interesting is that they try to list everything that can be found from wastewater and could be reused, recycled, and so it was a good start. It's not new to reuse water or to recycle water, but what is new is that maybe it's something more urgent to do or more mandatory in some place all around the world if we want more water and more development. So the change of paradigm, the typology what we used, conventional wastewater treatment, so WWTP is like that, and now we have the goal to shift it to a new name, which is called Water Resource Recovery Factory. So in this new definition of the place where we treat water, you can imagine a lot of technologies, and those technologies exist, have been proved to work. No worry. Right now, the goal is to apply it, to use those technologies, because we are not at the stage of finding new technologies, because those technologies exist, but we have to at the stage maybe to apply it in some case, in some region where it is mandatory for sure. And so yeah, I will try to focus a little bit more, to detail a little bit more what's going on in this water resource recovery factory. What can we have from from the wastewater? And mainly, if you have to remember main message related to those domestic wastewater, what we can find inside, mainly it's water. 99.5% of wastewater is water. Energy, we can recover energy from the wastewater, and also there are some molecules of interest which could be used for agriculture, like nutrients, or other bioplastics that could be made also with organics from the wastewater. So mainly remember this: wastewater are water, the majority, and then there is energy to get from, and there is also molecules of interest. So, yeah, like to introduce also this topic with these trending topics. So, trending topics that you may heard for other kind of situation, but we want to decrease the energy demand of all our systems, because there is also energy crisis in Europe related to geopolitical issues. We want to limit the climate change or the human impact on the climate change with greenhouse gas. So greenhouse gas issues are also something of interest for the development of new wastewater treatment plant. In some case, we want to decrease the extraction of natural water from the place where we are. So we want maybe to close water cycle in a circular mode economy. Some industry wanted to not to pay for water and not to discharge water to be treated. So they want to close the water cycle inside the industry. and maybe sometimes we call it zero liquid discharge, like something you are. Molecules of interest recovering, which could be, waste could be also something that you can sell also after that. So it could be also interesting to get something valuable from the waste. There are also some topics related to the emerging pollutants. So you hear about endocrine perturbator disruptors. You hear about microplastic, nanoplastics. You hear about pharmaceuticals and all those stuff that you can find in the wastewater. So this is also a goal because the conventional wastewater treatment plants were not designed to treat those molecules which are present at really low concentrations. Right now we are able to measure these concentrations, to find it at the inlet of the wastewater treatment plant, at the outlet, and in the river, and also in river which are really far from a city and from a human living place. So we saw that we have this impact of spreading those molecules, and we are the faculty to measure it. And now maybe we have to shift to try to fix it when it goes to the plant where we treat water, because it's it's a place where it goes at one point, and then we go to the natural environment. And also a hot topic is related to virus. So we have experienced virus crisis not so long. There is also topics related to bacteria, because in some place where we consume a lot of antibiotics, we can have the spread of some genes of resistance to this antibiotic, and it could be also some health issues and health crisis. So pathogens are also of really high concern for the future of the wastewater treatment. Okay, so try to get the different ideas into those four topics. So water, energy, environment, and feed with nutrients we can recover. So so I will try to go a little bit further into this different topic, and what is the main information related to those four. Water. So using water, we say non-conventional water resources. What does it mean? It means that conventional water resources are surface water, groundwater, maybe seawater could be also a non-conventional water resource, but use or treat wastewater are a non-conventional water resource. So, and also what is interesting is to fit for purpose. It means that you can fit the quality to the use that you want to do with this water, and this is really important, because when I was studying about wastewater treatment, we were talking about, okay, this is the regulations to discharge water into the environment. So, but there were no matter of not too much difference between all over the place in France. We had just to fit to the regulations. But for water reuse, this is not the case. It depends on what you want to do with this water, and depends where you are also. Because if you are in a coastal area or if you are inland, it's not the same situation. In coastal area in France, we discharge water into the sea. So it means that we take some fresh water, we use it, we treat it, and then we send it to the sea. We discharge it into the sea. So there is the fresh water was on the land, and it goes to the sea in salty water. So that's maybe an issue to solve. In some coastal area, wastewater reuse is really, really important. But maybe in inland, it's not the same situation, because if you use normally what is done is that you take some fresh water, surface water, for example, you use it, and then you treat it, and then you discharge it into the river. But if you use it for reuse, for agriculture, for example, it means that there will be no more water discharge into the river, and that could affect also the environment of this place. So we have to fit to purpose. So for purpose, so it means that we have to design our system on the quality and the amount of water we will use to the place where we are. for example, and to the also to the weather, to the climate, to a lot of things. Yeah, related to energy, so main information as what we want is to decrease the energy demand and to increase the energy production. So normally, wastewater treatment plant is a place where the city pay money to make the plant running, pay electricity, pay energy. But the goal is now that this place, the wastewater treatment plants, become a place where you can produce energy, and produce heat, produce gas, and could be used for energy or electricity production. Related to environment, so health issues, I already talked about it. Salt and nutrients, because also we have to be careful about what we do with the water, with the salts. Could affect the soil quality if we discharge too much sodium, for example, on soil. It changes a lot the quality of the soil, and then it could be difficult to grow for a long time something on this soil. Emerging pollutants, I already talked about it, and yeah, about the feed the world, valorize the matter. So it means that you can try, not because normally we use electricity to transform nitrogen forms into a wastewater treatment plant. Right now, we can say, okay, we want to keep the nitrogen into the treated wastewater because this treated wastewater will be reused for agriculture purpose. So we will have an economy of energy not to treat nitrogen, and we have the nitrogen economy also because we won't have to use chemicals, fertilizers for the growing of vegetables or something else. So yeah, the valorize the matter which are found into the wastewater is also a really hot topic. So irrigate, so give water, and fertilize, give nutrients. And there are also some issues related to the fact that when you do irrigation, if you irrigate with not with tap water or not with drinking water, you will have more maybe organic matter, maybe nutrients, and there could have also some development of bacteria inside the irrigation pipes. So those bacteria could be also pathogens, and there will be also could be a biofouling of the irrigation pipes. So there is also a topic related to that. So it was like maybe 1 month ago, I was in conference, and the guys from Spain show this really interesting concept of the history of water. So right now my talk is more dedicated to water, and yeah, I was thinking it's quite interesting to introduce this topic, this concept of water 5.0. So he was saying that the Roman system, which is known to be one of the first system of using water in a place where a lot of population came, but it was not the unique system. There were also Mayan system in Mexico and other places where antique civilization used water and tried to manage water. So it was quite a basic system. It means that they want to bring water to the population and trying to think that maybe it's better to discharge it far from the city. So they were starting to construct some pipes. And if you visit some place in Italy, like in Pompeii, or maybe Pompeii, but which is close from Napoli, Italy, you will see some antique Roman cities, and you see that along the streets they have prepared those channels for the wastewater, because the wastewater was discharged into the streets, but they wanted that the wastewater not stay in front of their homes, so there were like pipes it was not pipes, it was like channels. So this was the first basic water management. And then we shift to the water 2.0 because a guy, Jon Snow, don't know if he's maybe related, or Jon Snow is also a well-known guy from I don't remember the comic, but no, it's a TV show, but Jon Snow, Winter is Coming, something. Okay, so this is not this guy. This is another Jon Snow. So Jon Snow, he was a guy from UK, and at this time it was in London. He found that there were a link. He tried to take a map of London and he tried to put some spot where cholera, those disease, was spreading in some houses. So he was like with this map, he put a point, a spot, and after that he realized that maybe this spread of cholera was linked to the water, the water flow in the city. And so he make, for the first time, a link between the spreading of a disease and the flow of water. So yeah, because it was like the water supply, and the water supply was contaminated with cholera, and all the people, the cholera was spreading along these water supply lines or pipes. And so it was quite interesting because they understand, and it was it was the early 18th, so Pasteur and everything was, there were a lot of development related to health, and but this data mapping was also really interesting because it was linking health issues with water supplying or water management. Okay, and we go to the water 3.0. So at this time, we decided not to just discharge the water, but also treat the water. So we introduced the wastewater treatment systems. So you take the water from the natural environment, from fresh water, you use it, and then you waste it. So it was quite linear, no trouble of water in those places. But they were thinking that maybe treatment is necessary for the environment, for the health, and because they were realizing that if you discharge wastewater and there are too many people in the same place, you could have some trouble, eutrophication, and something you probably know. So we are going right now to the early of our century, so 2014, and a guy from David Sedlak from Berkeley University, he tried to conceptualize the water 4.0 concept, and he was trying to introduce circular economy, so what I was talking about before, so reusing some valuable resource from the wastewater into the water management. So it's not far, it was less than 10 years ago. So wastewater is water, nutrient, energy, and valuable compounds. And it goes to the water 5.0, which is something from the 2022 maybe. And they show that with a European project, they start to collect a lot of data from weather, from habits of consumption of the people, and also water, wastewater, water, and they try to also to include new way of smart cities and green cities and everything. So they use artificial intelligence and the big data mining and everything to imagine what is the future of the city and the management of water in the city. And also in this concept, there is also the fact that, as you know, wastewater contains a lot of information about the habits of the people. So with wastewater analysis, you can know if COVID-19 is in this place or not, or if it will spread in a few times, or you can know also the habits of consumption of drugs and everything. So yeah, this information that were in the wastewater now are able to be computed, to be assessed, and are used to imagine what's going on in the city and what could be the future. Okay, so if you are interested, type on Google Water 5.0 and you will have more information related to that. So I'm coming back to the basics of water. So what is wastewater? So wastewater can from different origin. We are more thinking about domestic wastewater, but there are also industrial wastewater, which is really specific. It depends also of the sewage network. Is it unitary or is it separative? what is the lifetime of water into the pipes, of the wastewater pipes. It's really important. What's going on when there is heavy rain in some place? Is there, so if it's separative, no problem. If it's unitary, it could have some trouble for the wastewater treatment plant. And we define pollution with those 6 characteristics. So 2 are dedicated to organics, so chemical oxygen demand and biological oxygen demand. There is the content of nitrogen, of phosphorus, suspended solids, and the volume of water that we 1% produce. So we define, and when we do sizing of wastewater treatment plant, we use in France we use exactly those data, but it could change a little bit all around the world. So, and what we do in a conventional wastewater treatment plant. So we got mainly wastewater are liquid, and the goal of the wastewater treatment plant is to discharge a maximum of liquid without the pollution parameters, without organics, without nitrogen, without phosphorus, to convert the pollution into a solid that could be what goes to a specific line. And there are some also byproducts linked to gas. So we produce CO2, we produce N2O, and what we use are energy and reactants that are used, oxygen to supply for the biological reactor, and coagulants also for if you apply coagulation. Okay, this is mainly what are the input and the output of a conventional wastewater treatment plant. And the goal, the initial goal in France was to be below those concentrations. So this is the regulation in France. I'm not sure about the regulation over there, but I'm pretty sure that it's really not far from that. So there are 2 columns. There is a maximum concentration allowed to discharge, and there is a minimum yield of removal. And if we are looking at the 3 parameters, so biological oxygen demand for the organics, nitrogen and phosphorus, mainly a part of those 3 pollution parameters are transformed into solids with new bacteria. Bacteria consume the dissolved compounds and produce new bacteria. When they produce new bacteria, they take a part of those compounds, but it's quite a small part. And the other part goes into gas byproducts, so CO2 for the organics, and N2 during nitrogen removal by nitrification, denitrification. And so we to reach those goals of standards, we use different unit operations. So some who are doing chemical or environmental engineering for wastewater treatment plants could recognize the different unit operations that we get there. We got the biological tank, we got the settling tank, could have also disinfection that happens sometimes, and here is the sludge line for the sludge. Okay, so this was the picture of the conventional treatment. And so what we can get from all this wastewater. So as I told you before, I wanted that everything is really clear for you. And remember this, wastewater is 99.8% of water. So as a scientist, you should know, and you should spread this to everyone, that it's mainly water. So when there is a human, there is some water somewhere, okay? So it's really important to get this in mind. And then you got all the organic matter, nutrients, and badly we get also micropollutants. So from water, what we can get is water to recycle into the wastewater treatment plant, because they use also water, or to reuse for different applications. We will go a little bit on this water reuse later. We can get also some thermic and hydraulic energy. Maybe there is something interesting I heard is that in Paris, France, Élysée is a place where the president is living and working, and they use wastewater from Paris pipes to heat this place. So the thermic energy from the wastewater, because it's warmer than the outside, is used to heat the Élysée Palais in Paris. So there are some energy in this. this could be hydraulic if we use different elevation, or thermic. Then what we get? We get the organic matter. Organic matter, so which is the main pollutants into the wastewater, could be converted into biogas by anaerobic digestion. So conventionally, when we treat the organic matter, we we use a lot of energy for aeration and to get some activated sludge and to degrade those organic matter into CO2 and water. But if we shift to the anaerobic treatments, we will be able to convert this organic matter into methane. And methane is a source for the biogas that could be converted into heat and electricity. Another hot topic in some research groups are related to the conversion of organic matter into biopolymers, or also to stop the anaerobic digestion at the volatile fatty acid step in order to get those volatile fatty acids, which could be used in other industrial processes. Nutrients, so nitrogen, phosphorus, and potassium are the three main nutrients for fertilizing. So nitrogen and phosphorus are really present in the wastewater. So yes, it's 1 hour I'm talking. No, I stopped before. That's fine. 40 minutes. But I have to go a little bit. So nutrients are fertilizers that could be used for agriculture. And for micropollutants issues, we have to take care about it in order to discharge a safer water and not too much disrupting the environment. So yeah, here I will pass really quickly, but it's the amount per person and per year that we can get from wastewater. So as you see, around 100 cubic meter of water, around 10 kilograms of organic fertilizers. So when you see those data, it's quite also interesting. You say for one person, so one person alone in a remote area, he can produce everything, all of that in 1 year, if we convert everything, if we recover everything. Okay. So wanted just to show you some quick information related to wastewater reuse regulations. So I found by preparing this speech that the first regulation that we have an information around the world was done in California. But what was really surprising for me, it was more than 100 years ago. So I'm talking about wastewater reuse. It's a new topic, but in some places of the world, and for example in California, it's not a new topic because that's more than 100 years that they have done some regulation related to that. And then there are also some really important things that happened in 1976 in the Orange County because of also some water shortage, and they had to increase the wastewater reuse in those places. And if we go to the regulations that we were waiting in Europe, for example, we have to wait for 2010 and 2014 to legalize wastewater reuse. Why I say legalize, it means that it was done, but without any law regarding to that. I found also that the last update of the US EPA related to wastewater reuse was for 2012, and the European Union regulations has been shown 3 years ago. Mainly, if you are, it's quite hard to read the regulations related to wastewater reuse, but if you want to give you the main information related to that, is that we can find different quality for different views. So it depends if you are, irrigating some trees or irrigating some tomatoes. You don't have the same quality to fit. And regarding the quality, there is also big difference all around the world, but mainly it's dedicated to pathogens. So they have got 3, 4, 5 indicators of pathogenic contamination. So in this example, it's Escherichia coli for I think it's the French one. And yeah, so this is pathogens are the main indicators of the quality of the wastewater to be reused, and the applications. So I talk about irrigation for sure, but there are also other applications that could be used, and it could be for fire fighting water. It could be for cleaning the streets. It could be to recharge groundwater recharge, for example. And what is really interesting is, for example, when you say street cleaning, you say, okay, the water has not to be so clean. We don't have to use drinking water for street cleaning. But the trouble is when you do street cleaning, you spread a lot of water, micro droplets of water. And if there is some mom who is with little kids, and a car goes to trucks goes to streets to clean the street, you can have the spread of those pathogens, because if it was treated wastewater, so it could have some pathogens inside, and that could have some health issue to the people who are not far from the street cleaning. So it's quite surprising, but street cleanings, we have to use the best quality of wastewater in terms of pathogen quality. We don't have to, it doesn't matter if there is some nutrients inside, but pathogens, it could be a matter for street cleaning. So as you see, this was just an example to show you that it depends what you want to do with treated water. The level of quality for pathogens, for nutrients, for everything is really dependent of the use. So fit to use. Yeah, and there are also in the regulation. Well, in the regulations there are some crop constraints. So I said before, it depends on what you wants to grow with this water. There are also some geological constraints. It depends on the quality of the soil. And also another idea is how to transport those water, because you treat water at the wastewater treatment plant. So you produce reused water. Okay, but what about the farmer who is like 50 kilometers from the wastewater treatment plant? How can he use this water? He has to construct a pipe, or he has to go with his trucks. So yeah, that's a really important matter related to wastewater reuse. So maybe in a decentralized way of thinking a city, wastewater reuse, or in a flat or buildings, maybe it's more adapted. But for the centralized system with a big wastewater treatment plant, we can produce some good quality water for reuse. But how to transport it to the people who need it? Not so easy. So there are some issues, and maybe civil engineering are involved in those issues too. So maybe I should have started with that, but it's quite interesting just to remember, because I'm pretty sure that everybody knows that. But the domestic use of water is only 10%, and the main wastewater that are used around the world is for agriculture, to make some food, and the rest is to industry. So when we are talking about water shortage or wastewater reuse, we are mainly talking about water for agriculture. That's why. But so it was interesting. So France, we are not the best, as you see, in wastewater reuse. We are 0.6, and Emmanuel Macron make a show. He say 1-2%, and maybe in 10 years we will be 10%. Okay, this is a good hope, a good goal, but right now we are not the first in Europe. As you see, those other countries more in south, like Spain and Italy, are more developed to this kind of application. And there are also some other places around the world where they had no choice. I was talking about California, but there is also really well-known examples of Singapore and Namibia and Gulf, Arabic Gulf, where there are a lot of issues related to water. So they are more advanced. So the different applications. For example, Israel. I've been to Israel, and in Israel, it was in 2011. 40% of the water used for irrigation was reused water, and right now I heard it's more 60%. So it's going, and at the end, they mainly irrigate only with the treated wastewater. But normal, because they are they grow some in the desert, so there is no water. or there is salty water in the ground. Another aspect which is really important is the social acceptance, because for example, in Singapore, people are drinking some reused water, which is diluted, but maybe they don't know about that, and maybe they have the choice to choose on the water, which is reused water, reused treated water, or water from the Alps, from the natural source groundwater. Maybe they could make a different choice as they have no choice. And so social acceptance is really something really important. So as scientists, we can know, and we could be sure that the water that we produce after treatment is clean water. It's maybe better than water in a bottle with all these plastics, but it's not so evident for everyone, and it could be also linked to religion or something. But yes, this aspect has also to take into concern, because it could limit the development of wastewater reuse. So yeah, the big examples of direct wastewater reuse for drinking applications are Namibia and Singapore. But in the other case, indirect use of wastewater for drinking water is something that is everywhere in the world. Because, for example, in France, you've got the Seine River. Seine Rivers are many cities, and all cities use the water from the river, and then they discharge in the river. There is another city, they use it for drinking water, they discharge in the river. And sometimes we say that at the end of the Seine River, when it goes into the channel in front of England, the water has been drunk 7 times before, or something like that. You understand? So yeah. So indirect drinking water production with water reuse is something. With wastewater is something really common. And also I have this company L'Oréal, which makes some cosmetics, and I visited their industry, or their plant facilities in close to Paris, and they say that they didn't consume any water. The only water they consume is the water that goes with the cosmetics that they sell. And inside the industry, they completely close the water loop. So all wastewater are not discharged, are reused into the process. So yeah, it was really impressive. And what is also impressive or surprising is that they didn't use it too much as a commercial argument. To sell more products, they don't say that they reuse water, and maybe it's linked that the fact that the social acceptance. When you buy products from L'Oréal, you say, okay, it's high quality cosmetic, and if they say that in our company we use only reused water, maybe some people would say, okay, it's L'Oréal. I'm not sure that I will put it in my skin, because that's reused water, so maybe the quality is not good. So it's an example really important to see that there's social acceptance. It's not so easy, because I think that for L'Oréal, for example, it costs a lot for them to reuse water, except of using drinking water. So for sure, it's more expensive than using tap water. That's part of the trouble also. They don't use it as a commercial argument. Maybe they are anticipating some regulations more drastic to people who are using water. It's a possibility. They were not so clear when I was discussing with them, but it's quite interesting to see that. Okay, so yeah, if we want to spend some time for discussion, I have to go really quick. So maybe I will short a little bit. Wanted just to make a focus on this drinking water production in Singapore with wastewater. So what do they do? Because you see, here it's crazy. Huh? In Singapore, they do wastewater treatment, classic commercial. And at our stage, we discharge this water. But after that, what they do? They do microfiltration. So they remove, after the settling part, some particles. Then they do reverse osmosis. So the process we use for desalination. So at the end, there is only water. They use UV to disinfect if it's necessary, but after reverse osmosis, there is no more. And then they do dilution with the natural water they use for drinking water, and they send it to the drinking water process treatment. So at the end, the water that you have in the bottle, because they put it in bottles also, and they brew also some beer with that. So this is a new brew, they call it. And but here in Singapore, they do it differently. They give the arguments, commercial arguments, that it's recycled water. But it's crazy. They do wastewater treatment plants. They add a big treatment, so reverse osmosis. It's really, really clean water, and then they mix it with natural water. So they got the really high quality of water. They mix it with a natural, surface water, and then they do the normal drinking water process. So I think that at the end we can be sure that there is no matter of trouble with this kind of system. But maybe we could make it a little bit more simple. But yeah, well, I think I will finish with that. We'll let the last part dedicated to energy. It's just to give you the example of what we are doing right now in Montpellier. So we got this European project, and we want to in Montpellier. So it's south of France, not too much water, really dry during the summer, really hot, and what we are doing right now is to design a truck with 4 different treatment lines inside big containers, maritime containers, that is on a truck. And this truck will go to the different wastewater treatment plants to fill some water tank like this, and with different quality. So we will have the quality to do water street cleaning, to do firefighting. We will have the water to irrigate some vineyards. We have the water to irrigate the gardens into the street, into the city. Different 4 quality of water with different line of processes. There will be reverse osmosis, nanofiltration, microfiltration, disinfection for sure. But it will be in a truck, and it will be a mobile system. So it goes to the wastewater treatment plant, he fills the water tank, and then it goes to another one. So we imagine like 2-3 different wastewater treatment plants in 1 week. So that's what we are doing right now. Okay, so sorry, I will skip the last slide related to energy, big data, a lot of things, but I will make my presentation available with Dr. Sam Snow, and if you want it, you can get it. No worry, I share it. I wanted just to finish by my conclusion slide. So my goal today was to show you the different possibilities, the different richness of wastewater for different applications. So I've done a focus on water, but there is also focus on nutrients, of energy that we can get from the wastewater. And to finish, I wanted to use this sentence: nothing is lost, nothing is created, but everything is valued or must be. Thank you very much.
Time for a question or two, and then I think we've got a little time to hang out if anybody wants to stay after. We'll find you, but maybe one or two questions.
Yes, please.
Thank you for the wonderful talk. As engineers, we are primarily focused on developing new technology and innovations that can increase efficiency of separation processes. But it seems that in places where water is pretty plentiful, right? Like Louisiana, we've got pretty clean groundwater, pretty plentiful. It's not unlike California or Florida where we struggle with thirst. How do you make the argument to improve water reuse technologies when cheaper surface water, groundwater actually isn't?
There is no big argument related to that. I'm sure that in Louisiana, I visited a little bit around. There is no problem of water. There is water everywhere, and with the technology we have, we can treat this water to make cheap water, drinking water, or water for irrigation. that's true, but we never know what goes on in the future. And as I told you, in France, it was not the case of big needs of wastewater reuse a few years ago. Well, I mean that maybe in Louisiana, when there will be some drought, it means that a big part of the world will be some with a lot of difficulties. So I don't have a clear argument, and you are true to make the point that at the end, the water we will produce will be with a higher price than the water we can produce with surface water. As you see from Singapore, they still have the drinking water process at the end, but before that, there are really, really expensive treatment lines. That's true, but maybe as an engineer, we can also work on the solutions for other place, and maybe for also, development when they use it also when they go like a mission to Mars or something, or a mission to the moon. They cannot get the water with them, so they have to recycle the water. And there is some specific scenario when there is no other solution than recycling the water. So as engineer, we can also help on those situations, even if it is not the case in Louisiana for sure. Okay, that's a good thing to say for the information. It's true that I did not know exactly the situation in Louisiana. I could expect also, ready to groundwater. Yeah, for sure.
How you have on here disconnected networks. Do you ever do studies with like just gray water versus black water? Because that's something I actually just wrote about for a paper in his class, Dr. Snow's class, was gray water treatment reuse. And so I know there's a lot of difference in like the total organic carbon available or that's present in like black water versus gray water. So okay.
Yeah.
Yeah.
I didn't have enough time. I discussed too much, but I will share my slides with Dr. Snow, and we can have also the discussion later. But yeah, that was part of my goal was also to talk about this source separation. I think it's really hot topic, and it's something really interesting because we are talking about grey water. For example, in my home, I'm using grey water for direct irrigation in my garden because I know that there is no consent for my plants. I can grow my tomatoes with the water from my kitchen. There's no problem. And at this scale, it's okay. There is also the direct urine use for fertilization, which is also really interesting because in urine you got this up. I wanted to show you this. So you see in urine you got like 90% of the nitrogen that you can find in the wastewater. So if you want to do fertilization, you separate urine. It exists. I don't know if you have in your course examples. There are some source separation toilets, and also they are building some. I saw some building in Switzerland where they do. In the basement you got the gray lines through the pipes. You got the black water. You got the yellow water. They use it directly. So that's. I think it's really interesting topic. Source separation, and even also we are talking about micropollutants. We are talking about, and if you avoid from discharging those pharmaceuticals into the wastewater, it gives you also a nice idea. Or some parts are difficult to separate, but that's a topic. Thank you for the question.
What is the main challenging to convince people to use the wastewater as a drinking water? Do you think?
Sorry, I didn't get it.
What is the main challenging to convince the people to use that wastewater as a drinking water?
To convince.
Yeah, the people, because people are not.
no, it's try to use what you know already as a scientist and say, okay, water is water. It's H2O, and I can. Well, no, I think that. But your question is interesting. That I think that we have to get more links with social science and humanities to find the clues to convince people related to water, because this is something that it's really hard. Even with my friend or my family, when I'm talking to them about water, they don't believe me. So I think that there are something to look at, yeah, with humanity. Some people are maybe more dedicated to this trouble, to this issue.
Last question.
Thank you for the interesting presentation. My specific field is away from water, but like it's interesting topic for all of us. So you were talking about the right side of water treatment plants and how that the treated water can be even better or like more pure than spring water. But from social acceptance perspective, I also wanted to know, or to, if you have any records, were there any mistakes that if that happened before that led to bad results? Like there should be some, right? Like were there some situations where a mistake happened in these water treatment plants and the output was not as expected or as hoped for?
Yeah, and I understand. I understand what you mean. It's true that you have to trust the system and the wastewater treatment system. But yeah, it's hard to answer to that. What I can say maybe is that a membrane is a membrane. It's physical separation, and you have also, so there is no way to pass through because of the size of the pores, for example. But what will happen is that the membrane breaks, so the water is not filtrating and it goes through the membrane without filtration, so it could have trouble with the quality at the outlet. But there are also some, some control, some.
So Scatman, for example, if this happens in the future, that this treated water, like this is widely used, can each house or each like district has its own detectors?
Yeah.
For example, that water is shut down immediately if an incident happens, or it's
Yeah.
not applicable.
Yeah, for sure, it's applicable and it's already in use. Yeah? And what I can say is also we are talking about spring water, but there could have also some trouble with spring water. If the source is contaminated, it could be it's possible. So those control are already in place, and but you are right that we have to be more careful because the direct contamination could be quicker. But I'm pretty sure that yeah, this is another part of the job. It's related to the control of the quality, but in terms of technology, engineering, it's possible. Control line
As
also.
an end user, if I
Yeah, for sure.
using this water, treated water, I would be more informed if I know there is a system close to my house that can detect and shut that.
Yeah, for sure. I understand. Yeah, but also maybe we don't have to misunderstand something. Is that using wastewater to drink it is it's possible, but it's the last. It's one of the possibility, and it's not the main possibility. Using wastewater to do irrigation, there is less risk. There is still some risk, there is less risk, and I think it's easier to do. But using for drinking, yes, you are in the spaceship Mars. You have no choice. You are obliged to do it. But yeah.
But it is tap water. Like,
Yeah.
we use it to,
Yeah, tap
like, it's close, to our faces.
Yeah, for sure.
So that's the thing, like, just talking about social.
Yeah, but as you see, even in Singapore, where there are a lot of water shortage, they mix it with the drinking water. So at the end, I don't know the percentage of wastewater that's in the bottle or in the tap water. I don't know the percentage, but it would be interesting to have this data. But
water here down in town, in Baton Rouge?
I drink tap water.
About half.
Yeah, it was in the.
About half. They buy water.
Well, it's another big debate. Tap water against bottled water.
Yeah.
Plastic against nitrate, maybe.
I always tell my students that I came from Atlanta, that's where I grew up, but in the Gwinnett County treatment plant, just below that is Dasani's water bottle thing. All they do is take that water, dechlorinate it, and put it in a bottle.
Cola figures out how to make a buck.
Well, thank you, Geoffroy.
Thanks. Can you walk me a reuse site that had the bladders? Looked like they were black bladders on the ground. Is that just a lightweight way to get storage?